Okay, today we'll do electromagnetic inductions. This electromagnetic induction. Now the word this electromagnet mean there is a chemistry between electric and magnetic field. Electromagnet. Clear? Now where current we have discussed earlier that when current is passed through a conductor, that conductor is behaves like magnet or behaves like electromagnetic. That means this we did. कुनै पनि कन्डक्टरमा if you pass a current, हामीले current pass गर्यो भने there will be a magnetic field भनेर. That means magnetic create हुँदो रहेछ that like conductor behaves like a magnet भनेर we discuss, no? That means in the electromagnetic inductions what we have to do, we have to take one conductor and magnet. Clear? हामीले electromagnetic inductions को लागि चाहिँ what we have to do, we have to take one conductor and magnet. Clear? And what we have to do, just look at here in the figure, when we will move conductor with respect to stationary magnet. Just look at here. This is the two magnet which will have south pole and the north pole, and this is the conductor. If you rotate this conductor, clear, यो कन्डक्टरलाई हामीले म्याग्नेटको बीचमा रोटेट गर्यो भने के हुँदो रहेछ, when we will move conductor with respect to stationary magnetic field, then EMF will produced. त्यहाँनिर EMF produced हुँदो रहेछ. Clear? अब stationary magnet भनेपछि म्याग्नेटलाई चाहिँ फिक्स राख्यो, only we have to rotate that conductor. Clear? अब now what is this EMF? EMF means electromagnetic force or voltage. EMF लाई हामीले के भन्दैछ, electromagnetic force or voltage पनि भन्दो रहेछ. Clear? And what happened, we know that हामीलाई याद छ magnetic field produced with two end of magnet, हैन? दुईटा magnet को दुईटा pole बाट, north pole र south pole बाट the magnetic field will produced. Clear? That means they will get the EMF जब त्यो rotate हुन्छ, जब त्यो conductor rotate हुन्छ with the stationary magnet fix बसेको जग्गामा, when the conductor will rotate, that time the EMF is generated. EMF generate हुँदो रहेछ. This EMF is generated in the कहाँनिर generate हुँदो रहेछ, in the conductor. That you have to remember. Clear? Now vice versa. अब तिमीले यही experiment उल्टा गरे रे, you keep the conductor stationary, fixed राख, नहल्लाइकिन. Only you will just move that magnet move गर, that time also the EMF will produced. त्यतिखेर पनि EMF produce हुन्छ. त्यो EMF केमा produce हुन्छ, in the conductor only. हामीले त्यसलाई experiment repeat, that means the opposite गर्दा पनि EMF will produce, and we know that EMF is the electromotive force or voltage we called it. Clear? Now with this we'll conclude that there is a relative motions between the conductor and the magnet. अब हामीले यो दुईटाबाट के conclude गर्न सक्दो रहेछ, that means there is a relative motions between the conductor and the magnet, then the EMF is generated is called electromagnetic induction. That means this is called the electromagnetic induction by the definition. And the concept of electromagnetic induction is proposed by Michael Faraday and Joseph Henry. दुईटा साइन्टिस्टले this electromagnetic inductions has proposed. कसरी propose गर्यो, when there is two stationary magnet को बीचमा चाहिँ, if you rotate the conductor, then the EMF will produced, and that EMF त्यही EMF चाहिँ कहाँनिर produce हुन्छ भनेर experiment prove गरेछ, in the conductor. That means the current induced, जुन चाहिँ current produce हुन्छ, that in the conductor, the current induced in the conductor is called induced current. त्यो produce भएको current लाई चाहिँ we call the induced current. Clear? Now how that current is flow. अब अर्को हामीले के याद गर्नु पर्यो, कसरी चाहिँ त्यो current चाहिँ in that conductor the current will flow. That means the current is flow where potential difference is there. potential difference आउने the current will flow. And another thing, you have to connect with that device, with that conductor, galvanometer, in order to identify the flowing of current. Current कुन चाहिँ magnetic field को current कुन चाहिँ direction मा छ भने that galvanometer will shows the that के shows गर्छ, that shows the deflections. Galvanometer which measures the potential difference, that is the voltage. Okay, now how potential difference is created within that, त्यहाँनिर कसरी क्रिएट हुन्छ भन्दा चाहिँ it is a electromagnetic force or EMF. That is, potential difference is nothing, it's a electromagnetic force or EMF. Or we can say when the conductor is rotated within the magnet. अर्को वर्डमा we can say when conductor is rotated within the magnetic field, or when there is a relative motions between the conductor and the magnet, then the EMF is developed in the conductor, which causes the current to flow in the conductor. This way the currents will flow. And this electromagnetic induction is induced by that it's proposed by the two scientists, that is Faraday and Joseph Henry, Michael Faraday and Joseph Henry. Now, to understand betterly, and another thing you have to remember, always with the conductor, that galvanometer has to connect in a series ma connect garnu paryo. Clear? To understand betterly this electromagnetic inductions, we'll do the experiment. Clear? We'll do one experiment. What you have to do, you just take one coil. Just look at here like this. Spiral coil, you take it. Clear? Now, this coil is act as conductor. Your coil secure, it's act as a conductor and connect two ends of coil with galvanometer. Clear? Voltage measure गर्नु पर्यो, deflection source गर्नु पर्यो. त्यसको लागि we have to connect यो coil को दुईटा end मा चाहिँ we have to connect with galvanometer. We have to remember that galvanometer always connect in a series मा connect गर्नु पर्यो. Take one magnet and then get 2-3 conditions. That means we have to take one magnet. Clear? अब हामीले अलग्गै एउटा म्याग्नेट लिनु पर्यो लाइक दिस. त्यो गरेर चाहिँ विल गेट द 2-3 कन्डिसन्स पाउँछ. अब त्यो कन्डिसन्समा म्याग्नेट छेउमा लाँदा टाढोमा लाँदा त्यसलाई स्टिल स्टेसनरी राख्दा कस्तो इफेक्ट्स विल गेट, that will observe it. Okay, number 1. Number 1 ma what you'll do, when we will place magnet near the conductor. Okay, garo the conductor cha, that is the coil, spiral coil, which is connected with the galvanometer. त्यसको छेउमा चाहिँ you just take one magnet like this. Clear? Magnet छेउमा लाँदा चाहिँ के हुँदो रहेछ भन्दा चाहिँ the galvanometer shows the deflections. The galvanometer ले shows गर्छ like ammeter जस्तै. लाइक हामीले कम्पास निडलले पनि डिफ्लेक्सन सोर्स गर्छ भने नि म्याग्नेटिक इफेक्ट छ. त्यस्तै ग्याल्भेनोमिटर त्यो म्याग्नेट छेउमा लाँदा ग्याल्भेनोमिटर अल्सो सोज द डिफ्लेक्सन, हल्लिन्छ. इन विच डिरेक्सन द ग्याल्भेनोमिटर सोज द डिरेक्सन्स, इन द लेफ्ट ह्यान्ड साइड्समा रोटेट हुँदो रहेछ. फर्स्ट केसमा वेन विल किप द म्याग्नेट टुवर्ड्स द कंडक्टरको छेउमा लाँदा. अब सेकेन्ड केसमा वेन वी विल किप द्याट म्याग्नेट अवे फ्रम द कंडक्टर. अब त्यो कंडक्टरबाट त्यो म्याग्नेट छेउमा हैन टाढो लाँदा पनि सेम वे इट विल सोज द डिफ्लेक्सन्स. ग्याल्भेनोमिटर सोज द डिफ्लेक्सन, द्याट इज इन द अपोजिट डिरेक्सन्स. अब फर्स्टमा छेउमा लाँदा लेफ्ट ह्यान्डमा छ भने टाढो लाँदा कहाँनिर मुभ हुन्छ, राइट ह्यान्ड साइड्स. Clear? This is the second case. And in the third case, when we will keep magnet stationary, magnet no हल्लाई जहाँ छ ती राख्दा that galvanometer will source. That means galvanometer ले केही सोर्स गर्दैन, आफ्नै जग्गामा बस्छ अरे. That means that will source nothing. Clear? That the galvanometer ले केही पनि सोर्स गर्दैन, जहाँ छ तीनिर बस्दो रहेछ. Here we'll have the 3 conditions. 3 conditions मा चाहिँ what we have conclude, okay, with this activity or with this experiment we can conclude that when we place the magnet near the conductor, that time the coil will shows the deflections. Clear? Deflections, and it shows the magnetic field. That means what happened ki on the result, that magnetic effect is larger. Magnetic lines of force will create it larger. Clear? And in the second case, when we'll keep the magnet away from the coil bara टाढो राख्यो भने magnetic field generate deflection source गर्छ, but that effect is lesser as compared to case 1. Clear? And in the third one, if you'll keep the stationary, that magnet stationary garda, there will be no deflections, means त्यहाँनिर magnetic field also not produced. Clear? That means there is no deflection, there is no generations of EMF. That means with this experiment we can conclude this. Okay, now what does that magnetic field represent? अब त्यो magnetic field चाहिँ के represent गर्छ भन्दा, that magnetic field represent the magnetic flux. Clear? अब कति magnetic field त्यो entered हुन्छ त्यो conductor मा भन्दा चाहिँ त्यो magnetic field नै we call the magnetic flux. A magnetic flux, what is magnetic flux? We have to understand. And before that, we all know the magnetic lines, magnetic line of forces. No, in the previous class also we discussed. For that also quick revision will do. Just look at here. This types of pattern, it's called the magnetic line. These types of lines will create. And we know in the magnet, the line always start from North Pole and end in the South Pole. Isn't it? Now, अब अर्को कुरा के याद गर्नु पर्यो, this types of magnetic lines will create it. And same in this experiment 1, 2, 3 मा पनि this lines will create. Clear? अब line चाहिँ के हुन्छ, छेउमा लाँदा बेसी हुन्छ, टाढो लाँदा कम्ती हुन्छ. Magnetic lines of force. And त्यसलाई नै we call the magnetic flux. And what is magnetic flux? Magnetic lines of force in a particular area is called magnetic flux. A magnetic flux भनेको चाहिँ के रहेछ? It's a magnetic lines of force in a particular area is called magnetic flux. This you have to remember it. Okay, that means we have clear in experiment 1, जब हामीले magnet छेउमा लाँदा what happen के हुँदो रहेछ, the magnetic lines will be maximum, means there will be the magnetic flux also increase if you keep the magnet nearer to the coil. Okay, and in the second case what happen, if you place that magnet away from the coil, what happen, magnetic field lines form is rare, means the magnetic flux decrease in this case if you keep the magnet away from the coil. Okay, and this changes, we'll see the changes when we keep the magnet near and away from the coil. What happen, that change in the magnetic flux produced, that means the changes हामीले changes पाउँदै छैन, and that changes produced EMF in the coil. That means change in the magnetic flux produced EMF in the coil. Changes चाहिँ कस्तो भन्दा चाहिँ magnet लाई अगाडि हैन coil को छेउमा र coil दिन टाढो लाँदा we'll see the magnetic lines को effect we are seeing हैन, छेउमा लाँदा magnetic flux increase, टाढो लाँदा decrease हुँदैछ. Now in the third case, हामीले जब magnetic त्यो magnet लाई constant राख्दा what happen, that time त्यहाँनिर के form हुन्छ, magnetic flux is constant, no EMF is generated. Okay, with this we conclude that when there is change in magnetic flux linked with the coil, then EMF is generated in the coil. Clear? That means the magnetic flux change by that links with the coil. The coil single linked to then EMF is generated in the coil, and that is detected with galvanometer, which is connected with the coil. And this is called the Faraday's law. This statement is called Faraday's law. Faraday has proved this thing.